Hello everyone, this is a video lecture for Business Calculus Math 1325 section 13.1 area between curves. So what does that mean? Well, let's just say that we have this function that does something kind of like this, and we have another one that does something like this, and they want the area between these two curves from A to B. So the area is just this area between the two curves. Ta-da! That's very simple. Like, that's actually all we're going to be doing today. Let's call these functions f and g. And so then, to be able to find this area between the two curves, you're going to go integral from a to b of f minus g dx, and there's your answer. I like a better formula, just me personally. I like to think of it like top minus bottom dx, and then you're done. Okay, so that's what we're going to be doing. I will be doing a lot of this by hand just because I feel like doing it by hand, but we can definitely use Desmos graphing for a lot of this as well. That's it. And I have in my notes, it says nothing new. So here we go. Let's go ahead and do it. We got y is equal to negative 4x minus the 5. And we have another function, y equals 0. And they say find the area between the two curves from negative 1 to 2. Okay. And so they say find the area. Well, we just need to set this thing up, really. It's going to be the integral from negative 1 to 2 of the top minus the bottom. Now, this is going to be interesting. I'm just going to pick something for the top and pick something for the bottom and hope for the best. And so I'm going to do the negative 4x minus the 5 minus 0. And then dx, I guess. Minus 0 is really simple because that just goes away. So we don't even need to write that part. We just need to integrate this thing. So when I'm integrating, I add 1 to the power, divide by the new power. This guy just gets an x, and I'm going from negative 1 to 2. And then I just plug in those two numbers. Now, you can see that I can simplify a little bit here beforehand. It'll probably make it easier when I start plugging things in. So plugging in the 2 into both of these, we get negative 2, 2 squared, 5 times the 2. So all of this, minus, plugging in the negative 1, I got negative 2 times the negative 1 squared, minus 5 times the negative 1. There's a lot of negatives going on there. So you can see here, I got a 4 times the 2 is going to be a negative 8, and then minus 10. So all this stuff minus on the inside. 2 negatives make a positive, but this is a third negative. So technically it's a negative 2. And here 2 negatives make a positive 5. And so I have a negative 18, and that's going to be minus a 3, negative 21. Sorry, negative 21. Yay! Now here's the thing. It says area between the curves. It's something like this. It's an area. And of course this graph here is going to be a little different. But can I have a negative area? And the answer is no. And so when they say what's the actual area, well, it's just 21 and you're done. I would say it's like the absolute value of it, but really what happened is I switched my top and bottom. At the very beginning, I had said this was on my top and this is on my bottom. But that is incorrect. It was actually bottom minus top, and of course that would flip everything. There you go. What I want to do is show you more like a picture, if that's okay, because I think that showing the graph picture makes sense a lot of times. So we got this guy. I guess we could put a y equals in the front there. And so we got these two graphs, the blue line and the red line, and they're saying from negative 1 until 2. So negative 1 is right here. And then we're going all the way to 2, which is out there. We could actually put lines to show that. So x equals negative 1, x equals 2. And so they're wanting to know top minus bottom, essentially, between the red and the blue from here to there. So it's almost this triangle area, but it's like cut off a little bit right there. Okay, so it would be a triangle, but it's cut off a little bit. Obviously, the blue is on top and the red is on the bottom, and that's why we got that negative, because I had flipped them. But all that's just the graphical. I mean, honestly, we could have just done integral negative 1 to 2, negative 4x minus the 5, and then minus the 0, doesn't matter, dx. Obviously, I got my negative again. Yeah, I would just have to flip it. To make it positive, I could just do this instead and see how they've got a positive. 0 minus this amount. Top minus bottom. Okay, cool. There we go. Let's do some more. So I got 13,121. I got y is equal to x cubed plus 12. And I have y is equal to 0, and they say go from 0 to 2. Now, I would say clearly this is on top this time. Everything's going to be way bigger here, and this is clearly on the bottom. So what I'm doing is going to be a good thing. Top minus bottom. So integral 0 to 2. Top. That's dyslexia there. Minus the bottom. Dx. And really, I mean, we could do this, just do it right here. And you might be wondering, hey, Chad, why don't we just do it right there then? Why do you continue down this terrible path of doing it all by hand when Desmos is clearly sitting right in front of you? Well, it's because I have to be a good teacher once in a while. I'm plugging into 2 into both of them. Here I got a 4, and that's a 6 anyways, so 6 times 4. So I got 4 plus 24 is 28, and we're done. Let's just verify because, well, I can. So integral 0 to 2, x cubed plus 12. There you go. Done. Next question. I mean, really, if you want to do some pictures with this kind of thing, you could draw them in Desmos, but here we're like starting up at 12 and then doing like a little cubic thingy, and 0 is right here, and we're wanting it from 0 to 2, so it kind of looks like this area right here. And so there you go. Okay. Next one. So 13,143. I got y is equal to 4x squared minus 4. I got y is equal to 0. And then it says go from -1 until 2. So I want to know what these look like before I decide what's on top and bottom. And Desmos is really good at doing this. So they're wanting to go from -1 all the way to 2. The green is on top. The blue parabola is on the bottom. So this is actually going to be the top, and this is actually going to be the bottom. And like if you want a proto picture of what it's kind of looking like, it's going to be something like this to this, I'm thinking. So it's not symmetrical. It's just some kind of area like that. Okay, so let's go and do it. So I'm going to say integral from -1 to 2 of top minus bottom. So 0 minus, and then I have my 4x squared minus the 4 dx. Okay. So that minus sign, of course, would distribute, and I'm going to add 1 to the power, divide by the new power. 2 negatives make a positive there. Oh, that just gets a plain old x from -1 to 2. When I plug this 2 in, 2 cubed is 8. With the 4 would make a 32 over 3. And then here, plugging it in, I got an 8. Minus, and then I plug in -1. 2 negatives are going to make a positive there, so positive 4/3. But here I'm going to just say -4. At some point, I just want to use a calculator, and maybe this is why Desmos graphing is actually a little bit better, because you don't have to do any of this stuff. 0. What? So here's the thing. I did not quite do the graph right. I said, hey, it's -1 to 2. If you notice where 2 is, it's right here, not right there. This is where 2 is. So it just kept going. In fact, what happened is that it was over here. It had all this area as well. Well, it just so happened that I got 0 area. Like I got all this 0 area? No, that's totally wrong. What's going on is that this over here is a negative area, and over here there's a positive, and they canceled each other out, essentially, to make a 0. So that's kind of a weird thing. The negative portion and the positive portion canceled. So I don't want to do that. Obviously, this is not good. I mean, you can think, well, just go ahead and put it in the calculator, and it'll do it. it won't do it. It'll be the exact same thing we just got here, so I'm just proving it to you. See? So that didn't help. What we actually need to find out is where is it crossing? And you can see on the graph it's actually crossing here at 1. So we need to separate this problem into two different portions. We got to say -1 to 1 and then 1 to 2. In a way, we're going to say, and I guess the negative area is a little bit bigger over here. So we got to have this negative area and then the positive area. And we have to just take these two areas separately and add them up. Okay, one's going to be negative. You just make it positive. And then the positive one, you just leave it positive. So this is what we're going to do. -1 to 1 of the exact same thing. So 4x squared minus 4 dx. It doesn't matter about the 0. It'll go away. And I want to find the absolute value of that. I want to find out what the actual area, like the number is, but I'm supposed to add it to the other guy. So I'm going to go from 1 to 2, do the same thing. And you're going to see that we're going to get a negative and a positive. It doesn't really matter that much to me. We're just going to try to find out what the numbers are, okay? So doing it all over again, blah, 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 blah. Nah, it's probably better just doing it here. You already did it once by hand. Why would we want to do it any more by hand? So you can see just how fast this is here. And then we're going to do it again. Huh. Isn't that interesting? They're the same number. And the reason why is because when I add them directly like this, what do I get? A negative and a positive will make a 0. I don't want 0 area. I know it's not just 0 area, but that proves and confirms why my integral above was a 0. Yeah. So what we're looking for is the absolute value of these guys. Well, this is already positive, but this one needs to turn into a positive. So this is what I'm doing. Back to Desmos. And there you go. So this is the total area now. Again, some of it was negative, finger quote, below the x-axis, and some was positive. But that's what we needed to do. Okay. So sometimes you got to watch out for those weird problems like that. That will pop up. Okay, so I got y is equal to x squared plus 2. I got y is equal to 2x minus 2, and they say go from -1 for x all the way until 2. I don't know what they like about -1 to 2. That's like every problem is -1 to 2. So I'm going to graph this on my own. This is just going to be a parabola, and this is a line that looks something like this. And we're going from -1 until 2. So I'm suspecting it's going to be something kind of like this. The parabola is definitely on top. This guy's definitely on the bottom, like the entire time. So all I'm going to do is do my integral. So -1 to 2 of, I got my x squared plus 2 minus 2x minus 2 dx. And we figure it out. So I'm always torn between doing this all by hand or not by hand. So I'm going to do it a little bit by hand. Let me go ahead and distribute this at the same time. So we got a negative 2x squared over 2, and then a positive 2x. And they don't cancel. Those will combine here. And so I got x cubed over 3. I got these guys cancel right there, minus x squared plus 4x from -1 to 2. There's another way to do this, and what you could do is type that function, essentially, in here to Desmos, and then you can plug in the 2 and then plug in the -1 manually. So I got 20 over 3 minus, and then I'm going to plug in a -1, and this is a negative, so it's minus a negative. 2 negatives are going to make a positive there. So I got 20 over 3 plus 16 over 3 is 36 over 3, which is a 12. And there we go. Cool. All right, 1,365. We got y is equal to x cubed minus 3x squared minus 9x plus 14. And the other guy is x plus 14. It says the area bounded by the graphs. So this is a little different. Area bounded by the graphs. So what does it mean by that? Well, let me show you. We're going to just do some Desmos. The first one's a cubic, so it's going to have like a wonky whoop. That's totally technical terms. A wonky whoop. And the other one is going to be a line. Let's zoom out a little bit. There we go. So I want to know what's between these two curves here. And what's going on is that we have this little bit right here. And then we have this bigger loop thingy right there. And so let me just kind of like protograph this thing. It kind of looks like this, and there's a line. So we're looking for this chunk and then this chunk. Now notice one of them would be a negative, or this guy would be a negative, and the other one's a positive. Basically, we need to know where are they crossing so that we can just split it up into two separate little areas. Very similar to when we got 0. So they're crossing right here at 0. Obviously, the 14 doesn't matter. I'm just saying the x value is 0. So I'm wanting to go for my first integral from -2 to 0, and then from 0 until 5. See where they're crossing? So this guy over here is at -2. This is supposed to be at 0. My graph isn't perfect, but you get the idea. And then this is a 5. So I'm going to do integral from -2 to 0, blah, 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 plus integral from 0 to 5, blah, 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 and I should get my answer. Okay. So top minus bottom. On the first one, my cubic is on the top. And so that's going to be top minus bottom kind of stuff. Let's start writing it, I guess. Cubed, 3x squared, minus the 9x, plus the 14. So all this stuff minus, and then my bottom was the x plus 14. Yep. Dx. So that's the first chunk. The next chunk... yeah, okay. The next chunk is very similar, 0 to 5, but now I'm going to flip it. So I got x plus the 14 and then minus all this other stuff. Again, you probably don't have to flip them because as long as you know that one is going to be a negative and one's a positive, you should be fine. So here, let's do it. Yeah, you can see that I gave up. I mean, this is really, it's an easy problem to do. These are all polynomials, so doing the integral is really simple, but it's okay to be a little bit lazy once in a while. So I got 8 for this whole thing. I got an 8. And then this guy, I mean, really, you don't even have to type this all over again because it's the same thing as last time, but you would just have to switch like your sign at the end. Blah, 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 blah. There. They're very picky about the parentheses and stuff. Just make sure you have parentheses around the whole thing, essentially, is what Desmos is going to want from you. So I got 375 over 4. Yeah, I guess. And so I'm going to go back here. 8 plus 375 divided by 4. And that's my answer. Cool. I have 2 more problems, and they're more application problems, at least a little bit. Okay, so it says that C prime of t is equal to 5, and then R prime of t is equal to 9e to the negative 0.4t. Now, they're talking cost and revenue, but these are rates. The rate of the cost at time t is a constant, so it's a constant rate. Versus here, it's a changing rate. And they say, what is the useful life of the game? So they're talking about a game, and we're going cost, revenue, and all this kind of stuff. So what's the useful life? I think what they're trying to do is like a break even. If you go and like graph it, what's going on is that we have this exponential decay, but we also have a flat constant line. And I think that they're wanting this area in between. Okay. So that's what my goal is, I think. That's what I'm thinking. So we need to find out where are they intersecting. Desmos graphing. I mean, really, I could do this by hand, and I think I will anyways. But if you type them both in anyways, it'll do it for you. Oh, not t, but x. Just a 5. So there we go. So they're at 1.469 is where they're intersecting. We can do that by setting these equal to one another as well. And so I would divide by the 9. And how do I get rid of an e? I ln both sides. Whoop. I can find that out here in a second. So ln 5 over 9 is equal to just a negative 0.4t. Divide to the other side. And there we go. There we go. Yep. So just like I had gotten from Desmos graphing. So that's not really my answer. This is the break-even point. I guess, I don't know if I would call it break-even, but it is when they're the same rate and all that. So I see on my notes, this is a little weird. What they're wanting to do here is wanting you to actually write 1 decimal place, and this is my time. And they want you to use the 1.5 for the rest of the problem. So what's the useful life? 1.5 years. There we go. And then they're wanting to find the area, which is going to be your total profit. And again, that's going to be revenue minus cost. But because they're both prime, when you integral them, you'll have the originals, and that would give you your profit, which is what they're looking for. So essentially, it's just top minus bottom once again. So integral from 0 to 1.5, not 1.4694. They want to use the 1.5. At least that's what I have in my notes here. So 9e.4t minus the 5 dt, and then figure it out. So I even said on my notes just to go right to Desmos with this one, and that's fine. It's not hard to integrate this thing. It's just not. It's not worth your time all the time, especially at this point in the class. We're really close to the end. You don't need to go and do all that by hand right now. I used x instead of t, but either way, 2.6517 would be your total profit over the lifespan of the game. So, oh, that's literally the other answer, total profit. You have to click that right there. Cool. Okay, so we only got one more, and again, it's a very simple one. It's a very quick one, 13.189. So we have w prime of t is equal to 0.2 e to the 0.12 t, and they're going from 0 to 10. I can't remember what the w was, if it was like a work thing or something, but they're just saying find the area. And this is... it's very simple. You're going 0 to 10 of this equation that they give you, dt, and you're done. And apparently that's supposed to be a total, which is fine. So you're going to click total on your homework. Once again, back to Desmos. We can do these integrals at this point. That's not the point. Okay, that worked with dt even. The point is, can you set it up? So 6, 6, and then an 8, 6. Okay, good enough. And that's it. That's all I have for this section. So thank you very much, and have a great day.